Hello students, welcome back to Ronak Sagi Pathshala. So, in this video, we will cover the basic concepts of structure mechanics and revise some numericals on the basis of that concepts. Okay, चलिए let's start. सबसे पहले initially we know stress. What is stress? Stress is equal to force upon area, force per unit area. Okay, strain is nothing but change in dimension with respect to length. We can say change in length upon original length, change in width upon original width, or change in volume upon original volume, change in height upon original height, anything. Okay, we all know within Hooke's law, within the limits of Hooke's law, stress is directly proportional to strain. Okay, so when we remove this proportionality sign, a constant comes, and this constant is nothing but Young's modulus of elasticity. So the value of Young's modulus we can find out from this stress upon strain. In one way more, stress, we can put the value of stress as force upon area is equal to E, and in place of strain, change in length upon original length. Oh, just a second. Change in length upon original length. So from this equation, we can find the value of del L as del L, change in length, is equal to PL upon AE. This is once again an important formula for calculating the change in length or elongation of the length with respect to load, area, original length, and Young's modulus. So these are some formulas which we are going to use. So आगे कोई फॉर्मूला होता तो आगे देखते हैं, नहीं तो अभी स्टार्ट करते हैं. चलिए, let's start. First question, we will start from basics. Okay, from zero basic. A structural steel rod has a radius of 10 mm and a length of 1 meter. A 100 kilonewton force stretches along its length. Calculate stress, elongation, strain. Young's modulus is given. So initially convert all the units in SI unit. Okay. So length is given as, length of the rod is given as 1 meter. Radius is given as 10 mm. We can convert it in meter as 10 into 10 की power minus 3 meter. Okay. Force is given as 100 kilonewton converted into Newton. 10 into 10 to the power 3 Newton. You can also write this as okay 100 है. Okay, just a second. This is 100. Okay. So you can write this as 10 to the power 5 Newton. Force is 10 to the power 5 Newton. Okay. Now, first step is to calculate stress. Stress is, we all know, force upon area. Value of force is 10 to the power 5 Newton. Unit is very important. Area. We all know that the rod, cross-section area of the rod is circular. So area will be pi r square or pi by 4 d square. You can take any. Pi into r square. R is 10 into 10 to the power minus 3 whole square. Value of pi will be, if you know 3.1422/7, you can write any value. But just calculator will put this equation in the calculator. The calculator will give you answer approximately 3.1 multiplied by 10 to the power 8 Newton per meter square. This is the value of stress. चलिए आगे बढ़ते हैं. Young's modulus. What is Young's modulus? Young's modulus is nothing but stress upon strain. You have strain? No, you don't have strain. You can calculate strain from this. You have Young's modulus. Stress upon Young's modulus. So 3.1 multiply by 10 to the power 8 divide by value of Young's modulus is 2 into 10 to the power 11. 2 multiply by 10 to the power 11. So strain will be approximately 1.5 multiply by 10 to the power 3. You all know the unit of it is strain. Strain is dimensionless. Strain is dimensionless. This is the value of strain you will get. Okay. Now, next we have to calculate what we have to calculate. Elongation, I think. Yes, elongation. Let's calculate elongation. Elongation is nothing but change in length. So, we all know strain is equal to change in length upon original length. From this equation, change in length will be strain multiplied by original length. So, multiply 1.5 multiply 10 to the power 3 and the original length is nothing but 1 meter. 1. So, change in length will be 1.5 multiplied 10 to the power 3 meter. This is meter. You can write this as change in length in mm, 1.5 millimeter. In mm, you can write it as 1.5 millimeter. Okay. Let's get to the next question.